Okay, 8.1. So we only do a couple sections out of chapter 8, and that's because this is really a setup chapter for Math 96, the next class that you would take after this one. So we do these two sections kind of as a overview review type of thing leading into that next class. These are all things in section 8.1, 8.2 that you've seen. So this first one is graphing and writing linear functions. Now we've seen functions and we've seen linear equations. And there's no difference between what we do with linear equations and what we do with linear functions. So the first thing we're going to talk about briefly is graphing linear functions. The second thing after that is writing equations of linear functions. And then just to touch on a topic that usually gets forgotten when students leave this class, we're going to go back to and take a look at some parallel and perpendicular lines. Okay, so this first example, graph g of x equals 2x plus 1 and f of x equals negative 3x minus 6. So here we have our function notation and we have our two linear functions, and we can see that these are nothing more than linear equations if you replace these with y's, y equals and y equals. And in fact, that's all it is a relabeling of linear equations into linear functions. So I'm going to draw some axes here. We're going to graph these on the same axes to keep things simple. So I'm going to scale by ones. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 8. It's 1, 3, 5, 7, 9. This is -1, -3, -5, -7, -1, -3, -5, -7, -9. Let's add the -9 in there. And then 1, 3, 5, 7. 1, 3, 5, 7, 9. So a quick little scaling there. So we're going to graph these in two different colors to keep things simple. Now, because these are just linear equations, all the little shortcuts, all the little tricks we learned back in chapter 2 and 3, we can use those. So when I look at 2x plus 1, I know that it goes through 0, 1, because that would be its y-intercept. And I know that it has a slope of 2, so it's going to go up 2 and over 1. So I have a point right here, which is 1, 3. Now you could also plot points. You could also solve for x and get your x-intercepts. All different strategies that we've used. Whatever your particular favorite flavor is, that's what you want to go with here. Remember, you only need 2 points for a line. Make sure you are labeling it. And because these are functions now, we can just label it by its function name, g of x. And that tells us everything we need to know, because g of x is 2x plus 1. Same thing for f of x. If I want to graph this, I know its y-intercept is 0, -6, way down here. And I know it has a slope of -3, so it's going to go down 3 over 1, or up 3 and left 1. So you can pick whichever you want to do that, but down 1 over 3, I'm sorry, over 1 down 3, bring us to 1, -9. So this here is 0, -6, and this is 1, -9. And we connect our dots. And we label this is f of x because it's got its own function name. So we're not going to spend too much more time on graphing in the lecture. You'll have a couple more in the homework to graph, but it's all the same techniques and strategies that we talked about in the previous chapter when we were graphing linear equations. Now we're just calling them linear functions. So those things directly translate over. So when we go to start looking at writing equations of linear functions, we want to think about the forms of the linear function, i.e. the forms of the linear equation. So the two most common that we're going to use are the point-slope form. Remember, point slope is y minus b equals m times x minus a. And this requires a point, a comma b, and our slope m, or another point. So we can calculate the slope. And that a, b, and m get slotted right into that equation. And then slope-intercept form, which is what the last two were forms of, y equals mx plus b. Of course, our y-intercept is 0 comma b with a slope of m. Now remember, there is the standard form of the line, but that's not very common when you're writing equations. You typically, if you have the intercept, you use slope-intercept. Otherwise, you go with point-slope, and you can simplify down to it. So let's just work through some examples here, finding different types of equations. So we're going to find the equation of the linear function whose slope is -3 and whose y-intercept is at 0, -5. So that gives us the slope and the y-intercept. So we can jump straight to our y equals mx plus b, which is -3x minus 5. And because it wants the function, not the equation, we switch this to f of x equals -3x minus 5. And of course, that's the easiest version when it tells us the slope and the y-intercept, just like it was back when we were doing linear equations. The next example is slightly more difficult. Find the equation of a linear function that contains these 2 points, 4, 0, and -4, -5. So I know that I'm going to need to do the point-slope form. With one of these points, I need to calculate my m. So remember, m is always y2 minus y1 over x2 minus x1. And so this is going to be -5 minus 0 over -4 minus 4, which is -5 over -8, which gives us +5 over 8. And then I'm going to pick this point here because it has a 0, and I like being lazy. So this is y minus 0 equals 5/8 times x minus 4. And simplifying, we get y equals 5/8x. And then 4 over 1 can simplify a little bit down to -5 over 2. But once again, we don't just want the equation here, we want the function. So we switch this to an f of x or a g of x or an h of x, whatever your favorite letter is. You can use f of x is just the traditional letter, 5/8x minus 5/2. And that would be our linear function that goes through these 2 points. Again, not any different than problems we've done before, just writing as a function at the end. The next example, what is the equation of the horizontal line through 2, 3? Is this a function, y or y not? So if we think about a little sketch here of 2, 3, horizontal line is going to go through here. Horizontal line means that the slope is 0, there is no change, which means that our equation is y equals 3, but that's not function. So f of x equals 3. Now I'm going to put a question mark here because it says, is this a function, y or y not? And the answer here is yes, it is a function. And it's as simple as, this will pass the vertical line test. Remember, that is our gateway into functionhood. Or in other words, that's how we tell if a graph is a function. So passes the vertical line test, or VLT. Remember that vertical line test. And our last example here, coming back to parallel and perpendicular equations. Again, we did this a couple times in a couple different sections, so we'll just do a quick little example to remind ourselves. Find the equations of 2 linear functions, one parallel and one perpendicular to the line 2x plus 3y equals -6. The parallel one should contain the point -11, 21. the perpendicular one should contain the point 1, 16. So the first thing I'm going to do is I'm going to rewrite this as 3y equals negative 2x minus 6, or y equals negative 2/3 x minus 2. And remember, parallel means that these slopes are the same. So I'm just going to take that negative 2/3 and slot it into our point slope form. So the point for the parallel is negative 11, 21. So this is y minus 21 equals negative 2/3 times the quantity x minus a negative 11. Minus negative makes it positive. So this is y equals negative 2/3 x plus 22 over 3 plus 21 over 3 is 63 over 3. So this is y equals negative 2/3 x plus 85 over 3. But we don't want the equation, we want the function. So we just switch this to an f of x equals negative 2/3 x plus 85 over 3. We've got our parallel line. And perpendicular, this is the harder of the two. It takes negative 1 over m for the slope. So we're gonna flip this to the reciprocal and make it positive. So our slope and our point here is 1/16. So this is 1 minus 16 equals negative 1 over m would be positive 3/2 times x minus 1. So this is y equals 3/2 x minus 3/2, and then plus 16. Plus 16 over 2 is 32 over 2. So this becomes y equals 3/2 x. 32 minus 3 is 29 over 2. And again, we don't want the linear equation, we want the linear function, and I'm going to switch it to a g of x since I already used f of x in the same problem. And that's going to be 3/2 x plus 29 over 2. So these are our two answers here. You could have used f again. It doesn't really matter as long as you make clear that they are different lines. But this is our parallel line and this is our perpendicular line. And this is the end of 8.1. A lot of review stuff. So every single problem we've done here, every single thing we've talked about, we already did in a different section. We're just kind of combining some stuff with functions and linear equations now.